All right, so this week you will have two different topics. The first one is solving radical equations and inequalities. So we'll go ahead and get started with that. That way we don't waste any time, especially since you only have 20 minutes each day to work on your assignments, okay? So it says solve the equation and check your solutions. You are not supposed to be using a calculator, okay? So keep that in mind. What I noticed first on number 1, and what we're trying to do is to solve for x, obviously, just as we did in Algebra 1. So we have a square root. How do I know it's a square root? Because there is not an index number here. So that automatically means that it is a square root. It's to be assumed that, okay? And to undo a square root, we would have to actually square it, okay? So I'm going to square both sides, and I'm going to be left with just what's inside, because a squared undoes a square root, okay? Undoes it. So I'm just left with what is inside the radical, okay? Our radicand. 3x plus 10 equals 8 squared, which is 64. Now that should be pretty easy to solve. When I subtract the 10, I get 3x equals 54, because whatever I do to one side, I do to the other. And divide by 3 so that I get a final answer of x equals 18. Okay. Number 2. So again, we're trying to isolate x. There's a lot going on there. But just like before, whenever you had two-step equations, you always add or subtract first. So you're going to add the 5 over first and then try to deal with all that. Okay? So we have 3 times the cube root of 2x, and that equals 21 now. Okay. Well, there's that 3 sitting outside of that cube root of 2x. We need to get rid of it so we can isolate the cube root, because then I can cube it. And if I cube it, it undoes it, and then I can deal with the 2x. And then I'll be well on my way into solving the value of x. So 3 is multiplying by that radical. I'm going to divide out the 3 on both sides. And I have cube root of 2x equals 7. Okay. And in order to undo the cube root, I cube it. Make sure you do it to both sides. So now the cube root's completely gone. I'm left with 2x equals 343, which when I divide that by 2, I get 171.5. Okay? Now, how can you check your solutions? Because it does say to do that. Basically, you're just going to replace x with the number that you got it equivalent to. So in the first one, x equals 18. Okay. Go ahead and plug in 18, which gives you 64, and square root of 64 is in fact 8. Okay. If you were to plug in 171.5 in for number 2, what you would find is that you had the cube root of 343, which is 7. And we'll multiply 7 times 3, which is 21, and then 21 minus 5 is in fact 16. I'm not going to write on that just because I want to save time. Okay, I don't want you spending a lot of time doing that, but I just wanted to make sure that you understood how to check your answer. Okay, so now it says that L is the fourth root of 2x plus 5.2. But if L is 6, what is going to be x? So it's still the same thing, but now we actually have to put the 6 in for the L and then solve. So 6 equals fourth root of 2x plus 5.2. Okay. In order to solve this, you're still going to need to subtract this 5.2 first. Okay. And then we can deal with the rest of it in a little bit. But go ahead and do that first. Subtract 5.2. Alright, so then you have 8 tenths equals the fourth root of 2x in order to undo a fourth root, you raise it to a power of 4, and so then you get 0.4096, okay? And that equals 2x. Now notice this does say calculator. Okay, you may use a calculator on this one. So in order to solve for just x, I'll have to divide by 2, which gives me 0.2048, which is the value of x. Okay. So moving right along, now we have a variable on both sides on number 4. So since everything's already moved over and the square root is now isolated, what I'll need to do is go ahead and square this and also square this other side here. Okay. Now, when it says x minus 10 squared, that doesn't mean x squared minus 10 squared. That actually means you have to write x minus 10 2 times equals just 9x. Okay? So, when I double distribute here, I get x squared minus 20x plus 100. Now, I did get negative 10x minus another 10x. That's where the negative 20x came from. But again, I want to save your time, and so I went ahead and simplified it for you. Equals 9x. Now, notice you're going to have a quadratic here. So remember all the different ways you can solve quadratics, whether it be factoring, quadratic formula, all that good stuff. You get to choose which way you want to solve it and solve for x, because this is non-calculator. Okay, you will need to show me how to do it by hand. So x squared, I'm going to subtract 9x and put it over here. X squared minus 29x plus 100 equals 0. We have to have it equal to 0 in order to solve for x, okay? So we have to think about, AC method. I'm going to try that. So 1 times 100, which is 100. Factors of 100 that make negative 29. I know, negative 4 and negative 25. Since A is 1, okay, then that means I can go straight to my 2 sets of parentheses, okay, straight to my binomials, x minus 4, x minus 25 equals 0. Okay, if you recall, what you'll have to do now is set each one of those equal to 0. Okay, so x minus 4 equals 0, x minus 25 equals 0. So your final answers would be x equals 4 and x equals 25. Okay, so notice your square root, the 9x, does not have plus or minus in front. So that means you can only have a positive root. Now, if I were to plug in 4, okay, if I were to plug in 4 back in, I would get, when I plug in the 4, I would get negative 6, because I have 4 minus 10, equals the square root of 9 times 4. And 9 times 4 is 36. But the square root of 36, since it doesn't have a plus or minus, it has to be positive, and this says it equals negative 6. Okay, that cannot be. So x equals 4 will not be a solution we will use. So our final answer would be x equals 25. Okay. All right, so then we come to number 5. We've got quite a bit going on here. Okay, so this one looks a little tricky. It's already set equal to 0, but that's not going to help me for this case, okay? What I'll have to do, because there are 2 cube roots, I'm going to put them on separate sides, because if I cube root both sides, then it'll undo itself, okay? But if I keep it on the same side, it'll make it very tricky, because I'll have to write this whole expression 3 times, and we don't want to do that. So instead, we're going to add this one over to the other side. Negative x squared plus 2. It's going to come over here. So 2 times the cube root of negative x squared plus 2. So what I have then is the cube root of x to the 4th minus 2x squared equals 2 times the cube root of negative x squared plus 2. Okay. So I'm going to cube root both sides because I want to undo, I'm going to cube both sides to undo the cube root. Okay. Now, when I undo the first expression here, all I'll get left is the radicand, x to the 4th minus 2x squared. When I do it on this other side, there was a 2 on the outside. That has to be cubed too. So this has to be cubed also, and that's going to give me 8. And 8 is going to be multiplied by negative x squared plus 2 because everything, the radicand is going to come out because it's been undoed by the cube. So if I simplify that, I have x to the 4th minus 2x squared equals negative 8x squared plus 16. Okay, so I'm going to go ahead and put everything to one side again. So I'm going to add the 8x squared over, and I'm going to subtract the 16 over. So I'm going to add 8x squared and subtract 16 so that my expression now on the left-hand side is x to the 4th plus 6x squared minus 16 equals 0. All right. We have 3 terms here. And I'm going to try to factor just like I normally do. And that my 3 terms are the x to the 4th, 6x squared, and negative 16. So I have to use the AC method. So 1 times negative 16 is negative 16. And I'm trying to find factors of negative 16 that make a positive 6. So that would be positive 8, negative 2. Okay, so since my A is 1, then I'm going to have my positive 8 and my negative 2, but it's not going to be x squared that starts our parentheses because it's not going to be an x. X times x is x squared, but we have x to the 4th, so we'll instead have x squared and x squared equals 0. Now, to solve, we actually have to have these, each binomial set equal to 0. So if I do the first one, I'll get x squared equals negative 8, because I set this equal to 0. And then I will square root that. And I get x squared equals plus or minus the square root of negative 8, which is plus or minus I square root of 8. And that's imaginary, so we don't want an imaginary solution. So let's try the other one, x squared minus 2. Let's see. Okay, so then we have x squared minus 2 equals 0, which is x squared equals positive 2. Square root that, and I get plus or minus the square root of 2. Since this is a cube root, we can have either a positive or a negative, so we'll go ahead and keep both of those. If you have an even root, that is not allowed. You cannot have the negative version, you must have the positive version. Okay, so let's go ahead and complete this section. We have 4x to the 3/2 power equals 32. We're still trying to solve for x. First thing I'm going to do is try to get rid of that coefficient in front of x by dividing 4. Okay, And I'm left with x to the 3/2 equals 8. Okay? I need to know just x to the first power. That's what I need, okay? So in order to undo 3/2 exponent, I will need to raise it to the reciprocal, the 2/3 power. So both of these will be raised to the 2/3 power. So this right here will just become 1 now, which is exactly what I needed. So this is x equals 8 to the 2/3 power. I'm going to rewrite 8 to the 2/3 power so you can see what it looks like as a radical. Okay, so remember the top goes with it, so it's 8 squared. And we need to take the cube root because that denominator is our index. Okay, so basically we have the cube root of 64. Okay, so the cube root of 64 is plus or minus 4. But since it is, however, since our original x that we were dealing with, so if we're plugging it back in, we have 4 times our x to the 3/2 power. That means x to the 3rd, which is squared. So it's a square root. We're trying to make it equal to 32. If we put a negative 4 in there, it's going to give me a negative. I can't take the square root of a negative. I will have an imaginary number. So I will not use the negative 4. My final answer would just be positive 4. Our last problem that we're going to do today, we will not get into inequalities. I want to kind of keep it condensed to just our equations, especially since we're doing the distance learning and making sure you have enough time to get it all done, and make sure you have only a 20-minute video. We'll do number 7. We're going to do the same thing we did a while ago. I want to make sure I get rid of that 2/3 exponent. So I'm going to raise it to the 3/2 power to undo it on both sides. So I have 3x squared minus 19 now, because that's all raised to the first power. So this just gets to stay as 3x squared minus 19. But over here I have 4 to the 3/2 power. What does that look like? Well, it's 4 cubed that's square rooted. Okay, remember this is always going to be the index of your radical. So I have 3x squared minus 19, which is the square root of 64. Oh, that's 8. So we have 3x squared minus 19 equals 8. When I add over the 19, I get 3x squared equals 27. Trying to isolate x, so I'm going to divide by 3. I have x squared equals 9. When I square root that, I get x equals plus or minus 3. We just need to see what type of root we had for our x in order to determine if we can have both plus or minus or only our positive 3. So if we take a look, we had 3x squared, which is raised to 2/3 power. Okay, so let's just deal with the x squared. Raised to the 2/3 power originally. Okay. So this was our index. It's a cube root, so I am allowed to keep a negative 3. So we'll have both the positive and negative 3.